Welcome back. Now, this question always comes to me that how to make a data normal. See, it is really, there is no straightforward answer that this is the way you can make your data normal. But always, sometimes you should transform to any other scale, say logarithmic, or try to square, cube, or try to take the square root, cube root, and so on. So after transforming, sometimes it becomes smooth and normality little bit increases. But perfect normal we may not know. And to solve this, Boxcox, the scientist Boxcox, he tried to do. He has suggested one of the way that there is just some transformation parameter. We call it lambda, and if you use that parameter, the probability of normality increases. That after transformation, it will be a bit more normal. Again, I'm saying it will not be the perfect normal, and you have the option to choose the transformed or the work with original. And just to let you know, see, these things we are doing just for your concept, and many of the advanced algorithm they take care of this normality things on their own, so you don't have to worry about. This is just for your concept only. So let us go ahead, and then the Boxcox are defined in multiple library. One of the library is mask. So we have just run the library mask. Line 98, we are taking the list of the predicted variables. And in Boxcox need the formula. So we are creating the formula in line 99 using this one. There is something called as formula. And these are the strings. If you see that, I'm printing it line 99. So if you see, this is the formula it has made. So you can print and see yourself, and it is the formula. What it is saying, MPG is the dependent variable, and all these are independent variable. And this is way how it is working. 103, we are doing the Boxcox, building the Boxcox model. It is taking the formula, the data which we are working, and plot basically this plot so that we can see the transformation. So what it is saying that if you do the transformation from this point to this point, the chance of getting probability will increase with 95% confidence. So this point to this point, somehow it's not mentioned, but it looks like it is near to minus 0.5. Okay, so that is what the lambda it looks like. And you can get the lambda into two ways. You can get the lambda 1 through this 104 through this function itself. And let us see that what is the lambda it has given. So if you try to print the lambda over here, and printing the lambda, it is giving minus 0.34. So it looks like this point is minus 0.34. Generally what happens if you go and do the transformation with this one, it is really sometimes it cannot be explained. But if you take just taking the minus 0.5, so minus 0.5 is what? It is a 0.5 means square root. A minus means below, so it is 1 by square root. This is a bit more too easy to explain. So 106 I'm hard coding 0.5, and this value is simply guessed after looking at this number. Okay, so in the it has gone up, sorry. 106 we are just hard coding the lambda, and how to transform and all the formula is already given over here, and this is the well-known formula. So this is the same, this is your original value, power to the lambda minus 1 divided by lambda. So we are creating a new column called MPG transformed, and this formula is given by Boxcox. So we are using that formula, so it has been transformed. And let us see the both things. So this is our original, and this has been transformed. So let us see that whether the transformed is really normal or not. So what we are going to do, 117 17 and 118. We are running it together. Okay, and yes, it has done it. So both has been done. If you see that this is our original and this has become transformed, so it means it still after transformation it is not looking that great. Not that great. Okay, so not that great. And I'll suggest you that if there are some other way to test a normality, definitely like QQ plot and few more through which you can also test and see it is normal, that transformed one is normal or not. And you'll find that from the look itself, it looks like it is not that much normal. So we are not going to do further. And 120 just to bring it back so that we can draw one by one. Otherwise, it will keep on drawing. One row, two column. That is the meaning of this. Excuse me. Now, inverse Boxcox is again formula given by here. Here at this one, the statistics book. And we have written a simple function over here in 123. And in 124, we are doing the inverse of that one, whatever we have transformed. So after doing the inverse, this is inverse and this is original. It should be similar or even if there is a difference, it should have very minimal difference. So I'm running 125. If you see it is saying true, it means yes, our inverse has also worked properly. This is just to show you that conversion to Boxcox and inverse Boxcox is also working properly. So here, even after doing the Boxcox transformation, we are unable to make it as a pure normal or perfect normal. So this generally happens. This happens in the practical data, so nothing new. And I wanted to show you because the data you may work with, you may not have the perfect data. So nothing to worry about. Many advanced algorithms which you will learn will take care of these things automatically. You don't have to worry. But at least you should be aware of that what is the Boxcox, how to transform, and how to make it normal and so on. So this is just for your learning purpose and nothing more. That's all for this one. Thanks for watching it. See you in the next one.